In this video, we will learn how to compute probability of dependent events. A university's leadership council is made up of 12 members. 4 are students, 5 are teachers, and 3 are deans. A newspaper reporter is planning to select 2 of the council members for interviews. The first member will be chosen at random, and then the second member will be chosen at random from the remaining members. What is the probability that 2 teachers will be selected? To summarize, we have 4 students, 5 teachers, and 3 deans, total of 12 members on that council. And we would like to know what is the probability of choosing both people to be interviewed to be teachers. 2 events are dependent if one event somehow impacts the probability of another one occurring. So when we are computing the probability of both chosen people to be teachers, notice there is a sequence of events. First member will be chosen at random, and then the second member will be chosen from the remaining members. When we choose first person and it's a teacher, the probability that the second time a teacher is chosen will be impacted because the pool of teachers is now smaller to choose from. Therefore, we have dependent events. And we are treating it as probability of first being teacher. We'll have to multiply by the probability of the second being teacher, given that the first was also teacher. So we have adjust our probabilities. Since there are 5 teachers out of 12 people to choose from, when we make our first choice, 5 out of 12 is the probability of choosing a teacher for the first time. Now that there are only 4 teachers left out of 11 members on the council, the second choice will be adjusted, and the probability this time is 4/11. We need to multiply these 2 probabilities because we have 2 consecutive events happening, and when we do, we get 5/33. We are asked to report the exact answer. We don't have to go into decimal form and round. Here's our second example. A pizza restaurant offers 13 different toppings. 6 of them are vegetarian and 7 of them are non-vegetarian. A customer selects her first topping at random and then selects another one at random from the remaining toppings. What is the probability that both her selections are non-vegetarian? Again, to summarize, we have 6 vegetarian toppings and 7 non-vegetarian, 13 total. Probability of both topics chosen to be non-vegetarian is the product of probability of first being non-vegetarian, or 7 out of 13, times probability of the second being non-vegetarian, assuming we already chose the first one to be non-vegetarian. And therefore we adjust the second probability to be 6 remaining non-vegetarian toppings to choose from 12 remaining topics to choose. And that gives me a product of 7/26.